Okay, so when we get into content-based instruction and assessment, you're going to learn, and this is going to be actually a core concept in TSL4081. But every content area revolves around concepts that are marked by certain language patterns or discourse. Okay, so your instruction in your assessment has to account not only for the content that you're teaching, but also for the language that you're using to teach that information, and the way in which that information is discussed in the book, or how we talk about that information. So you will notice that objectives always come in pairs. There's a language objective, and then there's a content objective. Okay, so the content objective of any lesson is going to talk about the concepts that you are hoping students will be able to complete or understand in that lesson. So for example, the content objective for assessment and instruction is the ability to add and subtract one-digit whole numbers. Okay, so that represents a skill that you're hoping students will be able to do at the end of a lesson. However, students don't do that in a vacuum, right? They need the language that goes along with that skill in order to demonstrate their ability. So the language objective covers that, and the language objective states, use math terms when showing addition and subtraction of one-digit whole numbers with everyday objects. Okay, so that would mean that in order for you to be able to assess whether students have the skill of adding and subtracting, you would also have to be able to see students using the math terms in the correct way to show you the addition and subtraction of those terms, of those numbers. Okay, and so in today's session, I just want you to understand that there are two sides to an objective. There's the language and the content, and that each one is actually very different, right? The content objective is the skill. The language objective is the language that the student has to use in order to showcase that skill. Okay, and then by having a lesson plan being guided by a content objective and a language objective, you're going to be making sure that your students are progressing in their academic achievement, but also learning the academic language that they need to showcase that knowledge. So let's get into the language and content of math. And the question is math a universal language? So actually, people have this idea and this sort of misunderstanding that math is the same wherever you go. And that's really not the case. While math may be somewhat easier for English language learners because some of it is not reliant on language, that's not necessarily true that math is sort of just a universal language. So the first aspect is that some of the algorithms, some of the equations are actually performed differently around the world. So we know that long division is done differently in the US versus in some countries in South America versus, for example, in South Africa. Some of the mathematical symbols differ, and I'm going to show you an example of this. So for example, the way in which we represent numbers, even those can be different, such as 1 and 7. Notice how 7 is actually represented differently. Here are also other different ways in which the US and Latin American countries write the numbers. Reading numbers is also different. We see that billion is written this way in the US versus this way in Latin America. The way in which we represent mathematical notation can be different. So we use commas in the US, whereas other countries, especially, for example, in Latin America, use periods. They also can represent the numbers in these different ways. Okay. -4 can look like 4 with a line on top of it in Latin America. Also, operation symbols. Notice how this operation, the multiplication symbol, is seen as a period, sort of in the middle in Latin America. In Latin America, they can also use the colon symbol to mean divided by, for example. Here are some other things. So geometry, angle notation is a little bit different. Even calendar dates are different. Okay, so in many other countries, the day comes first, and then the month, and then the year, for example. not the way that Americans have it. And this document goes through other ways in which, for example, least common multiples are different, algorithms are different, the formats in which you write aspects of math are different. And so hopefully that showcases to you that there's a lot to do with math that is different in different countries. There also are multiple terms for one math concept. Okay, and the grammatical structures that we use to communicate some of the ideas can change. So let me give you an example. Imagine you're a first grade teacher and you draw a couple of circles on the board, right? And your whole aim is to have students to be able to add and subtract, or at least to provide you with a total number of circles that you've drawn on the board. Okay, so think about and jot down the possible language patterns that typically would be used to relate the addition problems to your students. Okay, so it would be something like you might ask some of the following questions. How many are there altogether? How much do you have in all? What is the total? 4 plus 3 equals what? Combine 4 and 3 for your sum. Or count the two groups of circles. Okay, so each of these, all of these questions, even though they are very different from one another, they're using different key terms, and you can see that I've highlighted some of them for you. What they're all asking for is the same thing. But look how many ways we can represent the same question in math. So this is just an example to you to show you that we really do have multiple terms for the same concept in math. And you can see that each of these questions begin with different words and have varying grammatical structures, even to communicate the same idea. Another thing to keep in mind is that mathematic terms can have other meanings too that can be confused with high frequency everyday words. So for the term table, right, which we can use in math, right, table where we can write our results, maybe of a graph, right, that is something that we also use in social studies, in science, and in language arts, right? So language arts, maybe it's the reference of the actual wooden table. In science, this would be the periodic table. In social studies, it would be maybe a table that has a list of dates, right, about different events. So we really have to be careful with making sure that English language learners know the particular definition, the particular meaning of the mathematic term that we're using. I actually skipped this, but just to show you, here are all of the different ways in which we can communicate addition in math, right? And plus, more than, altogether, increased by. I mean, there are a number of ways in which we communicate addition. Similar with subtraction, right? These are all the ways in which we can denote subtraction. And so for English language learners to be successful in math, in English, they need to understand that those are all the ways in which we mean subtraction, right? And they have to learn all of those ways. It's not just as easy as minus and plus. There's also difficult nuances in sense and structure and meaning. So how many are left could be confused with how many to the left. Percent off can be confused with percent of, right? Two very different things. And there's also in math a lot of complex noun phrases. And remember, noun phrases, complex noun phrases would be a lot of adjectives placed on the noun. So you see denominator, the least common denominator being our noun phrase. Denominator is the noun, but you see that we have two adjectives, least common, being modifying that noun, the denominator. And an English language learner has to know that all of those together are referencing one aspect, one sort of concept. Same thing here, 2/3 the base price. So they have to understand that complex noun phrase and understand what it's actually referencing, right? And in that case, base meaning the final price, or the beginning price, whatever it's referencing. And they have to understand that base is actually an adjective describing price. And just in general, math really does have some dense and contextualized language that teachers have to be aware of and have to make explicit to their English language learners, right? That's something that you have to specifically go through and define for them and describe and show them images of to make sure that students are understanding and able to keep up. Also, ELLs have to solve math problems through language, oftentimes. So, a grade 3 item such as 12 children went to the beach, some of the children went swimming and some played in the sand. There were twice as many children playing in the sand as swimming. How many children were doing each activity, right? There's a lot of English language that they have to go through to understand what the actual equation is that they're working from. Same thing here. A class has 12 children. There are twice as many girls as boys. How many girls and boys are there in class? Okay. So notice here that the teacher has put 12 in numerals and twice as in 2 times. Those aspects would help ELLs, as well as going through maybe helping ELLs to learn how to create the equation that they're working with from the question. In this question that we saw above, I mean, think how many of the terms that they would have to understand in order to get that equation. They'd have to understand beach, they'd have to understand some, and the fact that some of the children is that noun phrase, and some is modifying children. They'd have to understand swimming, and some played in the sand. And here, some of the children went swimming, and some of the children played in the sand. The important information is not really swimming and playing in the sand. I mean, the children could have been doing anything. The part that they have to understand is that those children are now going to be grouped as separate, and that's what the equation is going to be based on. Okay, so going through that information with ELLs is highly necessary, because without that explicit instruction, there's going to be an information gap for them. Here are some other strategies to make math problems more accessible to ELL students. You can create a glossary with definitions on the side. You can bold the keywords, and I would choose the key math terms, such as how many, for example, or twice as many would be another key term that I would bold, because I know that students are going to see those terms again and again across questions. Include diagrams, charts, and tables whenever possible, and provide the relevant formulas, if possible, to help students through. Okay, so let's do our first activity around math language. And I'm going to have you read the following math problem. And what I want you to do is think about and circle the potential problematic areas for English language learners in this problem. Okay, think about why you've circled the parts that may cause difficulty for ELLs, and think about what you would do or say to clarify these items during a math lesson. Okay, and you can always think back to some of the strategies that we've reviewed. This activity is actually available on a sheet that you can open and print if you need. That is available in the Blackboard unit that we're in right now, where you're watching this video. Okay, so I'm going to give you a moment. You can pause the video, read through the question, think about what aspects of this question would be problematic for ELLs and why. And then we're going to talk about what we could do instead. Okay, so let's go through it. One of the first sort of parts of this question that might be problematic is some of the key terms. So, for example, volume. We know that volume is a key term in math, but we know that it also has different meanings across content areas, right? Volume could mean the amount of noise, right? How high the noise is. So that is a concept that would have to be clarified for ELLs. The fact that this word problem has a lot of nouns about places, right? The names of places, General Sherman Tree, and the Sequoia National Park can add confusing factors to the problem, right? Imagine if we just said the largest tree in the world by volume has a diameter at the base of 36 feet, right? It's not really necessary that that students know it's the General Sherman Tree or that it's in the Sequoia National Park. So those are aspects of the equation that if you were going to try and help ELL students, that you might take out of the question right? Or explain those aspects to students. Base is another one of those terms that have different meanings, right? So you would want to, so that could be particularly problematic to ELLs. And also to help them, you might want to add an image or sort of a chart that shows the base of a tree, right? Feet, again, feet has the two meanings. And outstretched is a sort of a weird, not weird, but maybe not a very common way in which to describe arms, right? So instead of or in addition to having outstretched arms, you might want to include a picture with a person standing with their arms outstretched, right? So this way ELLs can make the connection between arms that are stretched out, right? And the way that it's described right there. Reach around might also be something that's challenging for ELLs, because reach around is a verb, but the verb now contains two parts. The verb itself, reach, and a preposition, around. And these are called phrasal verbs, which can be a little bit confusing for ELLs, because an English language learner would have to know that reach around together makes the verb, right? It's not separate. Okay, so here are just some of the aspects that may be confusing to ELLs. Ways in which you could clarify these items is to provide definitions or descriptions, to talk about some of these aspects before you have them complete the task, the question, to take out some of the non-essential information, like the General Sherman tree, right, the Sequoia National Park, and to have, when possible, diagrams to clarify some of those aspects. Okay, another part, I didn't highlight it, but just to keep in mind, another part that might provide a challenge for an ELL is to understand that the way that they're answering the question is to tell us how many people, right? So that 6 feet is going to be one person, so their answer is going to be actually representing how many units of 6 feet. Okay, so if they can't understand the language, they're definitely going to be caught up in providing how many units of 6 feet, and understanding that from the way that this is worded. Okay, so just some things to think about. Again, just for you to be aware of how math can be difficult for English language learners, and how it is your responsibility as teachers to be explicit about this in order to ensure that you are providing culturally valid assessment.